Dear need student, let's see that atomic fundamentals, the basic of atomic number, mass number, and isotope, isobar, isotone, isoterer, and isodiaphers. Those we will see this video. Initially, the atom is the smallest part of that, smallest part of there is a matter. Okay, smallest part of matter. Okay, so here this atom as a general name. So those atom it possesses, there is a representation. If you assume as x here, z and a, so this x is a symbol of atom. This a as a representing as a mass number. Okay, mass number. And z as a represent as a atomic number. Okay, atomic number. So we will see this mass number, atomic number, and the symbol like that. So generally, the atomic number is nothing but if you assume as a neutral atom. Okay, neutral atom. Neutral means as a equal of positive as well as negative charges is there. Neutral means equal of positive and negative charges. So if you assume as a neutral atom, that equal to the atomic number of protons or number of electrons. Okay, number of electrons. So that is nothing but equal to of atomic number. In case ions, these ions is separating two types. One is a negative ion, another one is a positive ion. So if negative ions means here the electrons as a greater than protons. Okay, so if positive ions means there is proton as a greater than the electrons. Okay, so whatever that ions, the atomic number z as equal to 2 for number of protons. Okay, number of protons, that's all. So in generally, whatever that atom or ions, that is equal to of atomic number of protons. For example, the hydrogen H plus. So here hydrogen atomic number is 1. Here also is 1. In the case of hydrogen, the electron as a 1 and proton as a 1 and neutron as equal to 0. So here the electrons 0, protons 1, neutrons is equal to 0. Anyway, this neutral atom and ion both doesn't change in the proton. Proton does not change. Okay, so that's why the ions, the atomic number, that is equal to number of the protons. As mass number actually the sum of the nucleons, that is for mass number. For example, according to that Rutherford, he proposed that the central part of that atom, that is a nucleus. So that nucleus is entire mass of atom is consisted. So like that he told. So the sum of the nucleons are mass number. What are that nucleons? Nucleons are proton and neutron. These two particles are presented as the central part of that nucleus. Okay. So this proton and neutron, that is nucleons. The sum of the nucleons, that is a mass number. So mass number as representing as A, that is equal to proton plus neutron, that is for mass number. Suppose we get in that number of neutron. So neutron is equal to mass number minus proton. So number of proton what? That is equal for number of proton, because the neutron, the mass number minus proton, the number of proton, that is equal to for atomic number. So that's why these formulas can be changed. Neutron is equal to A, that is mass number, minus Z as a atomic number. So that is a new number of neutrons. For example, see this carbon 6 mass number as 12. Here the electrons, that is it is a neutral species, that's why here 6, and the proton, that is also 6, because proton whatever that ions are neutral, that is equal to of atomic number. So that's why there is a 6, and neutron is equal to, that is 12 minus 6, that is also 6. Okay, because the neutron is find out formula, that is atomic mass number minus atomic number. Here mass number as a 12 and the atomic number as a 6. So 12 minus 6 as a 6. That is the answer. Okay. Anyway, it is a very easiest, simplest, basic fundamental of atomic structure. Okay. Let's see that another one example. See the sodium 23, here is atomic number as 11. So here the number of electrons is equal to, this is a neutral species, so that is a 11 electron, and the protons equal to whatever neutral and ions, number of protons equal to of atomic number, so that is 11, and the neutrons equal to 23 minus 11, that is for the neutron. So here the neutron, that is equal to the 23 minus 11, what, there is a 12. Okay, there is a 12 neutrons is there. Suppose sometimes ions are given. For example, the magnesium 2 plus, the how many protons, how many electrons is there? Here electrons, actual magnesium as a 12 atomic number, mass as 24, it's a 2 plus state. So 12 electrons is not presented here because there's a 2 plus, 2 electrons is after loss out, it will become, that is a 2 plus. Magnesium, whenever 2 electrons is loss out, it will become to that magnesium 2 plus. So that's why here is a 10 electrons is there. And proton, this ions, but doesn't change its number of proton equal to of atomic number. So that's 12, and the mass number, that is equal to of 24. So here there is a neutron, that is equal to 24 minus 12, that is neutrons equal to of 12. Okay, so this kind of that method, whatever that any atom, we can find out the number of electron, number of proton, number of neutron, mass number, atomic number. So those all, everything we can easily find out. Okay. Next, isotope. Iso means same. Okay, so anyway, the given species, someone is the same, must be someone is a similar or same numerical value. Here the isotope, they have same atomic number. Okay, that's a same atomic number but differ the mass number. So those as equal to for isotope. Okay, that's all. For example, see the hydrogen 1 1 and hydrogen 1 2 and hydrogen 1 3. So these all are, there is a atomic number, these all are, there is a mass number. So the atomic number is equal to 1 1 1 and mass number is equal to 1 2 and 3. Okay, so that's why the same atomic number but different mass number. So these all are, that is a isotopes. Okay, so then for example another one category, there is a carbon 6 carbon 12, and here C6H C6 13 and 6C 14. Here there is a Z and A. The atomic number what? There is 6. Mass number is 12, 13 and 14. So anyway the atomic number does not change, but that mass number is only changed. So that's why these are there is a isotopes. Okay, so there is a very easiest, simplest way to finding that whether there is isotope or not, like that. So whatever that the given species, the atomic number or same element, the different mass number is presented, that is called isotope. Okay, isotopes. The next is a isobar. Okay, here there is iso means as a same. Okay, so here somewhat is a same numerical value. Here there is a the mass number as a same, here is a mass number but differ as a atomic number. Whenever that atomic number differ, the entire element also is changed. So that is one thing you keep it your mind. Okay, so for example here the argon, there is atomic number 18 and mass number is a 40, and potassium has a 19 atomic number, mass number 40, and the 20 calcium atomic number, mass number is a 40. Here the atomic number and mass number, atomic number what? 18, 19, 20. Okay, so this mass number is a 40, 40, 40. So whenever that the same mass number but different atomic number, so that's why those kind of the elements or ions, whatever that is under the category of the isobar. So simply see these all are, that's a different element because the atomic number is different, that's why that element also different. Okay, so in case of the different element has the same mass number, that elements all are, that is a isobars. Okay, then isotone. Okay, the next as a isotone. Tone means, you keep it your mind, that's a neutron. Tone, that pronunciation is almost similar. That's why here the same number of neutron. Here what is the same? That is a number of neutrons. Number of neutrons as a same. In case of different, there is a atomic number or there is a mass number anyway. So like that, the species that under the category of isotone. For example, see, for example, the carbon 14, there is 614, and the nitrogen 15, and there is a oxygen 16. Okay, 16. Here, see the number of neutrons, that is 14 minus 14 minus 6, how much? 14 minus 6, how much? Yes, 8. And 7 minus 15 minus 7, what? That is a 8. 16 minus 8, how much? 16 minus 8, yes, very good, there is a 8. Okay, so here the atomic number, that is equal to 6, 7, 8, and mass number is equal to 14, 15, 16. Anyway, the atomic number and the mass number both as a differ, but in the case of number of neutron only as the same. So number of neutrons only same, that's why these category under that isotone. Okay, so it's a very very important. Isotone means there is a same number of neutrons are presented. Okay, next see that is a isoterror. Isoterror. Okay, that isoterror, that is a here the same the size, same size or similar size. Okay, similar size, as well as the valency electrons as the same. So those kind of there is a species or isoterror, but differ is as previous like that, there's atomic number or there's a mass number. Okay, those are the different. So for example, see in the case of 8 atomic number containing oxygen power of 2 minus, and 9 atomic number of fluorine as a minus, and 10 atomic number of neon. Okay, see here there is a atomic number as a 8. So anyway, the number of electrons in the case of valence cell, that is the 6 electrons, p orbital, as well as s orbital as a 2 electron. So that is a 6 plus 2. For example, the oxygen, there is a 1s2, 2s2, 2p, there is a 4. So this is the valence cell. Okay, there is 2 plus 4, there is a 6. So here the oxygen has a 2 minus. So oxygen power 2 minus. So that is why that is equal to of 1s2, 2s2, 2p6. So there is 6 plus 2, there is a 8 electrons is there. Okay, so anyway, the number of electrons that is equal to 8, and here also is a valence cell 8 electron, here also is a 8 electrons. Okay, so for example, there is a F minus, there is a 1s2, 2s2, 2p6, and in neon here is a 1s2, 2s2, 2p6. So those all are, there is a valence cell containing 8 electrons, that's why here 8, 8, 8. And the atomic number as a 8, 9, and 10. So anyway, the number of electrons are same, and as well as the atomic number are differ. Okay, so those kind of species are under the category of, there is a isosterer. Okay, there's isosterer, that kind of category. Okay, the next is isodiaphers. There is a isodiaphers. Okay, isodiaphers. So these isodiaphers has the same number of differences between neutron and proton. Okay, here what is the same? Same is equal to for the differ of neutron and proton. So that is a same, but differ as a atomic number, or there is a mass number, or sometimes both. So those kind of that the species under the category of isodiaphers. For example, see the thorium atomic number 90 and mass number 234. So here the number of electrons, what? There is a 90, and number of protons, what? There is a 90. Number of neutrons, there is a 234 minus 90. So the 234 minus 90, how much neutrons are there? Yes, there is a 4, that is a 144 neutrons is there. Okay, okay. So the proton minus and or the neutron minus proton, the here neutron has a 144 minus proton, how much? Yes, there is a 90. So there is a differ, neutron minus proton differ, we can get that is a 54. Okay, this 4 is came and 14 remain is there, minus of 9, that is a 5. Okay, that's a 54. There is a neutron minus proton differ, neutron minus proton differences, that is a 54. And that is a similar case of similar in the case of uranium 92 238. Okay, here electrons as a 92 and proton as a 92, and here neutrons is equal to, that is 238 minus 92. Okay, so neutron is how much? The minus of 238 minus 92, how much? That is a 146. Okay, so here the neutron and proton differences, neutron minus proton differences, neutron how much? As 146 minus the proton how much? As a 92. So we can subtract these two, we can get as a, that's 4 and remain as a 5, that's a 54. So that's why the thorium 90 232 as well as uranium 92 238. So these two as a isodiaphers. Okay, isodiaphers. That is a very easy topic for that atomic fundamentals. Let's see that the upcoming video for electromagnetic waves and spectra in the atomic structure or structure of atom unit of NEET and JE level. I think you will learn in that content. If you like in this video, subscribe and share your friends. Thank you very much.